Okay, so take time right now to go ahead and pause the video and copy down the title. GG.5 is going to be pretty quick, and most of our time will be spent learning how to do GG.6. Both of these are dividing polynomials, but GG.5 is when you are going to divide by a monomial. Okay, quick reminder, a monomial are things like x, 2x squared, or 7, because they all have one term. It's okay if they have a number or a variable or a combination of the two, as long as there's no plus or minus. So our example, we're going to do two examples. If we have 10p to the fourth plus 7p cubed plus 3p squared, and we are dividing by p. Because this is a monomial, very similar to if I was multiplying, I can basically distribute this to all of them. So I'm going to write this as 10p to the fourth divided by p plus 7p cubed divided by p and plus 3p squared divided by p. And again, this is only because it is a monomial that I can do this. Okay, now I can think about this. P to the fourth divided by p, that's going to become 10p cubed. The p on the bottom will cancel, and this will reduce by 1. Same here. So this will become positive 7p squared, and p squared divided by p is just p. So this would be my final answer. In this case, I have no remainder because all of my terms here had a p that could be divided out. Now we're going to look at a different example where you might have a remainder. So we have negative 9c minus 20 plus 5c cubed plus 73c squared, and we are dividing this all by c. Okay, now, you know what, let's divide it by c squared. I take it back, we'll just stick with c. When we divide this out, I can divide each of these by my monomial because it is a monomial. Okay, so c cancels. This doesn't cancel, so we'll come back to that. Here, the cubed becomes a 2, and that c cancels. This square goes away, and that c cancels. So if I were to put this in highest degree, my highest degree is this 2 right here. So it would be 5c squared. And then the 73c, and then the negative 9, and then this right here is technically my remainder because the c didn't cancel. So I'm going to do minus 20 over c, and that is going to be my final answer. Now, if I had, let's say, 5x squared plus 10x to the 7th, and I want to divide it by 5x squared. 5x squared is still a monomial. I can still divide. I'm going to write it underneath every single term. Okay, now, in addition to having a variable, I also have a number. So I'm going to look at the numbers. 5 divided by 5 is 1. X squared divided by x squared is also 1. So this term just becomes a 1. 10 and 5 reduce to be 2 and 1. And then x squared divided into x to the 7th, we subtract. So that would become a 5, and that cancels out to a 1. So this is now positive 2x to the 5th. All of my denominators have 1s. So I have no remainder, everything canceled, and that is my final answer. Okay, that is GG.5. Now we're going to move on to GG.6, which is long division. All right, so think about long division when we have numbers. Let's say we want to divide 758 by 3, okay? If I wanted to do that, I would normally write 758 divided by 3. So see how the 3 came on the outside? Okay, now how many times can 3 go into 7? 2 times. And I'm going to multiply 2 times 3 to get 6. And I'm going to put that directly below the 7. Now I want to see how much is left over, so I subtract from 7 and I get a 1. Now I'm going to bring down a 5. And I'm going to start the process over again. I'm always looking to say, how many times can that 3 divide into 15 now? Well, 5 times, and 3 times 5 is 15, so I have no remainder, but I still have another number here. Okay, 3 can go into 8 2 times. 2 times 3 is 6. I'm going to subtract, and I get 2. So this is my remainder. And I can write this as 252 and 2 over 3 because I'm still technically dividing 2 by 3. I just can't divide it evenly. Now we're going to do that whole thing with polynomials. All right. First example. We have negative v minus 3 dividing by v plus 3. Now, notice how the thing I'm dividing by is more than one term, so I have to use long division. So we want to put v plus 3 on the outside. Okay, that's what we're dividing by. And then negative v minus 3, I'm going to put on the inside. Quick reminder, this needs to be in standard form. So highest exponent first. And we want placeholders for missing terms. So like if I have an x squared plus 9, I'm going to write it as x squared plus 0x plus 9 so that I have degrees that go down 2, 1, none. And again, my degrees come from my exponents. Okay. So now I want to say, okay, how many times can I get negative v divided by v? And I'm ignoring everything else about each polynomial. I only want to look at just the first term of each polynomial. So negative v divided by v is negative 1. So that's going to go up front. Now, I'm going to multiply negative 1 times both terms. So that becomes negative v and negative 3 because it's negative 1 times the whole thing. And then just like what we did up above, we subtracted each time. I'm going to do that same thing. So I'm going to subtract this whole thing. Well, luckily, it's identical, so there's no remainder. So my answer is just negative 1. Now let's try one where there's a remainder. So let's say we have 5b plus 3, and we are dividing by b plus 2. So I have to put b plus 2 on the outside because that's what I'm dividing by, and 5b plus 3 on the inside. Okay, they're both in standard form and we have no missing terms, so we're good. Now I want to look at the leading coefficients, okay, 5b and b. I'm ignoring the rest because right now it doesn't matter. So 5b divided by b, well, that's 5. So I'm going to put a 5 up here, and I'm going to multiply 5 by all terms. So we get 5b plus 10. And again, I need to subtract to find the difference. So 5b minus 5b is 0. 3 minus positive 10 is negative 7. So my answer is going to be 5 from here. Oh, sorry, I forgot. Because negative 7 can't divide by b, I'm done. So this is going to be my remainder. So now we can say that my answer is 5. I'm going to put the minus out front so that I can have the 7 on top without the minus, and then b plus 2 comes on the bottom because that's what I was dividing by. All right, there's a lot of steps here, so let's practice one more time. Let's do a longer problem so you can see the pattern. We have 2g squared plus 19g plus 54 divided by g plus 5. Okay, g plus 5 is what I'm dividing by. That goes on the outside, and it's in standard form. I have degrees 2, 1, and none, so I'm in standard form here, and no missing numbers or places. Okay, so now I want to look at just the leading coefficients, okay? 2g squared divided by g is 2g, so that's what I'm going to put up top. Let's change the color of that so you can see where I got those. Okay. Then we are going to multiply 2g times both terms. So I get 2g squared plus 10g. And I have to find the difference, so I'm going to subtract. 2g squared minus 2g squared is nothing. 9g squared minus 10g is 9g. Now, I can keep dividing, so I'm going to bring that 54 down, just like I did in my other problem at the very beginning. And now, instead of looking at, now this is my leading coefficient that I'm going to divide by g. So if we do 9g divided by g, that is just 9, so positive 9. I'm still going to multiply that by both, so I get 9g plus 45, and I need to subtract to find the difference. 9g minus 9g is 0. 54 minus 45 is 9. If I do 9 divided by g, because that's my leading coefficient now, I can't, so this is my remainder. So my answer is 2g plus 9 from up here. Okay. And then this is a positive 9, so I'm going to do plus 9 over g plus 5. All right. This is your homework, and you're going to work on this on IXL for GG.5. You only need to get it up to 60, and if you get it up to 80, then you get extra credit.